We are going to look at optimization in terms of business and economics. Business and economics are strong users of optimization because there are a lot of different things in a business setting or an economic setting that you want to get the best outcome for, the best return on your investment, the most profit, the least amount of cost, the least amount of product waste. Things like this are things that can be optimized in business and economics. So the first thing we're going to do is look at a few different equations and a few different formulas and a few different vocabulary words here that we need to make sure we're familiar with so that next we can go through and solve a couple different types of questions. So the first thing we have here is the cost function. Well, the cost function is C of Q, and it is the cost to produce some amount of some product. Well, that some amount is what we're going to call Q. So we're going to start with our last one here with Q, because Q is the number of units of a certain product that we're talking with. So let's get that one down first, and then we'll go back and fill in the others. So Q is the number, so I'm just going to abbreviate it, of units. So like 3 TVs, 100 cars, things like that. Of a certain product. And then we can go back and fill in the cost. So the cost we said was the cost to produce some number. Well, that some number we're going to call Q. So the cost function is the cost to produce we're going to call it Q units of a certain product. And then marginal cost is the rate of change. So that should sound familiar, rate of change of cost to produce Q units. So the marginal cost, notice that prime right here, so it means a derivative. So the marginal cost is the derivative of the cost function, and it's the rate of change of cost. And then the average cost is just what it sounds like. It's an average. So it's the overall cost divided by the number of units that you make. So for example, if you have an assembly line, maybe the first couple units on the assembly line have a higher cost because you're setting up the assembly line, you're gathering all the materials. So maybe if you make 1, it costs more than if you made 100, for example. So the average cost would spread out that upfront cost for getting everything set up to all of the different units that you produced. So it would create an average of the cost of all the units. So this is where it gets a little bit tricky. The average cost is lowercase c. The cost function is capital C. So we have to be careful to make sure that we are differentiating between the two different ones. So lowercase c of Q is equal to big C of Q divided by Q. So the cost divided by the quantity. So here are our brief overview of our terms. When we are looking at average cost being a minimum, then the marginal cost and the average cost are going to be equal. So just a note there. So when you are looking at your average cost being at a minimum, then the marginal cost, the rate of change, and the average cost are going to be equal. We'll see that as we come down through. So let's try this first question here, and let's see if we can apply what we have been talking about. So for number 1, we have the average cost of producing Q units of a commodity is C of Q equals 21.4 minus 0.002 Q. Find the marginal cost at a production level of 1,000 units. In practical terms, what is the meaning of your answer? So let's see if we can solve this down through. The first thing that we need to recognize is we're looking for the marginal cost. See right here, find the marginal cost. So that means that we're looking for C prime of Q, and that's capital C. The best I can do for the notation is I try to put a little stem like this on the capital C and no stem on the lowercase c. So hopefully that will help differentiate between the two different ones. So let's see what we can do here. The average cost. Okay, so average cost, that is C of Q equals big C of Q divided by Q. And that's our average cost. We got that down. Is 21.4 minus 0.002 Q. Okay, so let's start with that. So that equals 21.4 minus 0.002 Q. There we go. Now we need to get our marginal cost. Well, in order to get our marginal cost, we first need our cost function. And our cost function is just this numerator right here. So first we need to get just the numerator so we can get big C of Q equals. So in order to get just big C of Q, we need to multiply both sides by this Q so we can get it out of the denominator. So if we multiply both sides by Q, it'll look like 21.4 minus 0.002 Q squared. So we have big C of Q, the cost function. So now we need the marginal cost. So we need C prime of Q. Forgot to write my Q. I said it and forgot to write it. Let's go back and put that on there. There we go. So then what we did, just to review, we multiplied by our Q. And when we multiply by Q, we have 21.4 times Q and 0.002 Q times Q, making it Q squared. So then we can take the derivative. So the derivative becomes 21.4 minus the derivative here will be 2 times all of this and then bring down your power by 1. So that'll be 0.004 Q. So what does it say? It says to find the marginal cost at a production level of 100 units. So that means Q is 1,000.